learning about motion. Under motion, there are various terms used in motion. Number one, we have in distance. When I speak of distance, what comes in your mind? Distance, by definition, it refers to the length between two fixed points. If you have the points A and B, we have the near point A, we have the near point B. The length of points A and B defines distance. Therefore, distance refers to the length between two fixed points. Now, the S side of distance is meters, meaning distance is measured in meter. However, distance is a scalar quantity. And then our second term is displacement. We have in part B as displacement. By definition, displacement refers to the distance covered in a specific direction. Displacement is the distance covered in a specific direction. Like in this case, displacement has same SI unit with distance. They are both measured in meters. The distinction of distance and displacement is that displacement is a vector quantity, whereas distance is a scalar quantity. Of course, scalar quantities are quantities with only magnitude but no direction, whereas vectors, they are quantities having both magnitude and direction. Therefore, displacement is the distance covered in a specific direction. And then our next term under motion is speed. Now, speed correlates with distance. Speed is the rate of change of distance. In other words, speed is equal to distance divided by time. Therefore, speed is the rate of change of distance. And therefore, of course, distance is in meters. Time is in seconds. This comes up giving us meters per second, meaning speed is measured in meters per second. Speed is the rate of change of distance. And then our next term is called velocity. By definition, velocity is the rate of change of displacement. Velocity is the rate of change of displacement, meaning velocity equals to displacement divided by time. Velocity is equal to displacement divided by time. Now, displacement is in meters over time is in seconds, giving us meters per second, meaning velocity and speed have the same SI unit of meters per second. The distinction is speed is scalar quantity, velocity is a vector quantity. And then our next term is acceleration. That is part E. Acceleration refers to the rate of change of velocity. Acceleration, by definition, is the rate of change of velocity. That implies acceleration is given by change in velocity. Acceleration is given by change in velocity divided by time. However, acceleration, of course, in this case, velocity is in meters per second, divided by time is in seconds. This S goes upwards, giving us meters per second squared. Mean acceleration is measured in meters per second squared. Accelerations are of two categories. One we have in Roman number 1, uniform acceleration. Uniform acceleration. As I spoke before, acceleration is the rate of change of velocity. Therefore, when the rate of change of velocity is constant, we say it's uniform acceleration. Therefore, uniform acceleration refers to the constant rate of change of velocity. For this one, if I draw a graph of velocity in meters per second, this one again is tiny. This graph is a straight line graph. This implies the change in velocity with time is constant. And secondly, our number 2, we have non-uniform acceleration. This one is the opposite of the first one. This is when the rate of change of velocity is not constant. Therefore, the graph of velocity in meters per second, again, is time. Now, this time in seconds, the graph is not straight line graph. And acceleration, we have the Roman number V, that is retardation. Retardation. Sometimes called deceleration. Retardation, this refers to a negative acceleration. Meaning, if I draw a graph of velocity in meters per second, again it's time. Time in seconds for retardation, this graph is like that. It's negative graph. Then likewise, acceleration can be constant. We have in Roman 3, that is constant. Roman 3, Roman 4, that is constant velocity. Now, if I draw a graph of velocity in meters per second, again it's time in seconds. For constant velocity, the graph is a straight line graph. This means you have no acceleration. For constant velocity, we have in 0 acceleration. A becomes 0 meters per second. And then our next term, or our next subsection under motion is the equations of motion. We have the equations of motion. I recall defining acceleration as rate of change of velocity. Acceleration is the rate of change of velocity, meaning acceleration is given by change in velocity divided by time. The word change means difference. Velocities have two categories. One is called initial velocity. Initial velocity. Now this one, where is used u, meters per second. U means initial velocity. 2 we have in final velocity. For this one, where is used v, v meaning final velocity. When I say change in velocity, I mean difference. Change means final velocity minus initial velocity. So I would say acceleration is given by final velocity minus initial velocity divided by time. And I put over 1 and I cross multiply, I'll have v minus u is equal to at. This comes that side, giving us v equals to u plus at. This becomes our first equation, motion. Then, secondly, I can define displacement. Displacement S. Displacement is given by average velocity times time. In this case, velocities are of two categories. One is initial and one is final. Average means you add and divide by 2, meaning displacement S is equal to average velocity times time, giving us S equals u plus, remember the v is u plus at. U plus at times t divided by 2, giving us S equals 2. This becomes 2u plus at times t divided by 2. If I expand that specific bracket, I'll have S is equal to multiply this t inside, giving us 2ut plus at squared. This becomes 2ut plus at squared and divided by 2. These two divide to both quantities, giving us this over 2, the 2 will cancel, this over 2, giving us at squared divided by 2, which becomes ut plus a half at squared. This becomes the second equation of motion. And then lastly, using same expression, using this as my star, so from star, which says displacement s equals to average velocity divided by time. Now, from the first equation, from this one, number 1, when I make t the subject, t becomes v minus u divided by time. Make t the subject, giving us t equals to v minus u divided by a. Put this t there. So say this will give us s equals to u plus v divided by 2 times our t, which t is v minus u divided by a, giving us s equals to, multiply this with this, giving us u plus v into v minus u, this times that, this becomes 2a, giving us s equals to, this one is given to squares, becomes v squared minus u squared over 2a, cross multiply, v squared minus u squared equals 2as. This goes that side, giving us v squared equals u squared plus 2as. This is our third equation of motion. Meaning, in summary, motion has 3 equations. Summary. We have in v equals to u plus at, we have s equals to ut plus a half at squared, and we have in v squared equals to u squared plus 2ax. Let's have examples. They said a car accelerates uniformly at a speed of 20 meters per second for 4 seconds. Then they say find number 1, final velocity if acceleration is 2. Meaning step number 1, so is the question. The car accelerates at a speed of 20. This 20 is our initial speed. 20 meters per second is our u. The time taken, it is 4 seconds. And then the acceleration we are given, it is 2 meters per second square. And they say find the final velocity. You will recall from, we have 2 equations. We have in v equals to u plus at, we have s equals to ut plus a half at squared, and we have v squared equals u squared plus 2s. Meaning from these ones, they say find final velocity. Meaning given these ones, you can find this v using the first equation so easily. So I would say using v equals to u plus at, v is final velocity, the u is 20, plus the acceleration, which is 2, times time, which time is 4, giving us v equals 20 plus 8, giving us v as 28 meters per second. And then secondly, they say find distance traveled. You can find distance traveled using either the second equation or third equation. Using second equation, which says s equals to Roman 2 ut plus a half at squared, my distance traveled becomes u is 20, our time is 4, then plus a half, our acceleration is 2, times time, which is 4 squared, that is 16, giving us here an 80 plus by 2 ones, giving us 16. So I'll say distance traveled s is equal to 96 meters. Our second example, he said a model car is brought to rest. Now in this case, not some two ones. When I say car is brought from rest, if I said from rest means u is equal to 0 meters per second. When I say a car is brought to rest means v equals to 0. Not these ones, there is from rest, and there is to rest. Here they say the car is being brought to rest. To rest means v equals to 0, meaning in this case, if I summarize the question, my v would become 0 meters per second. Why? It's being brought to rest from a speed of 108. Now take note, convert this to meters per second. How? I would say my u would give us 108 multiplied by 1000 divided by 3, 600. Why? Because 1 kilometer has 1,000 meters. Likewise, 1 hour has 3,600 seconds. Now dividing up, I'll have my u as 30 meters per second. Then they say in 15 seconds, meaning time equals 15 seconds. Then they say find the acceleration. Don't forget, I told you acceleration, that is a, it is v minus u divided by time. My v is 0. Why 0? It was brought to rest. My u is 30, and my time is 15, giving us negative 30 over 15. So I would say in this case, my acceleration is negative 2 meters per second squared. This one is same as retardation. We could say retardation is given by now positive 2 meters per second squared. After the example, they said a car starts from rest. We saw very well that from rest means u equal to 0 meters per second. And they said and is accelerated uniformly at a rate of 1 meter per second squared, meaning this one is our acceleration. We have in A as 1 meter per second squared in 20 seconds. Time becomes 20 s. Then they say find the final velocity. For this one, you would use v equals to u plus at. Which u is 0. Why is 0? Brought from rest. That's the acceleration. It is 1 times 10, which is 20, giving us 0 plus 20. Therefore, our final velocity becomes 20 meters per second. And then secondly, they say find distance traveled. To find distance traveled, you can use any of the equations. You can use the second one, which says v squared, which says s equals to ut plus a half at squared. Our u is 0. Our time is 20 plus a half. Our a is 1. Our time is 20 squared. That becomes 400, giving us 0 plus by 2 ones, this becomes 200, giving us distance plus 200, giving us distance as 200 meters. However, someone else could still use the third equation of motion, which says v squared is equal to v squared plus 2as. The v, we saw it was 20 squared plus u, which is 20 squared is equal to u squared, it is 0 squared plus 2. Our a was 1 times our s. 20 squared, it is 400, is equal to, this is 0, this becomes 2s, over 2, giving us s as 200 meters. Both can still work. We're learning about